Welcome to another session of Technology by Performix. I'm Ken Umansky, your host, as we explore the world of technology. Today, my guest is John West, a pioneer and expert on blockchain. John started blockchain work in 2016 when he led blockchain R&D for Thomson Reuters. Since 2019, he has independently consulted with large corporations and software vendors to help them apply blockchain and Web 5. He also advises startups and has two startups of his own. John is a founding board member and advisor for the Texas Blockchain Council. He founded Dallas Blockchain Meetup, which is the most prominent blockchain meetup in Dallas. He founded McKinney Bitcoin Meetup. He served as a founder and tri-chair for the Tech Titans Blockchain Forum. He chaired the taxation committee for the Accounting Blockchain Association. He has also served with business negotiators and on the blockchain committee for the Dallas Startup Week. Welcome, John. I'm really happy you joined us today. And man, that is a really impressive resume. And thanks for taking the time to be with us. Blockchain, cryptocurrency, Bitcoin are all words we hear every day, but I don't think many people understand what they mean and the differences. I think my audience, and I know I'd like to understand these ideas more. So let's start with a little background on those words, if you would, and those concepts. And then I have some questions for you, I think, that we'll have a good discussion with.
Yeah, thanks for having me, Ken. It's a honor, it's a privilege. It's always fun to speak about these things. So, yep, very happy to be here. Yep, that's a really good way to start it. It's just looking at these terms, blockchain, crypto, Bitcoin, even Web 5. What do they mean in simple terms? Really simple, backing up to the beginning, that everyone knows or has a sense that it all started with Bitcoin, right? And people looked at Bitcoin and then they looked at, well, what's the technology under Bitcoin? And it was blockchain, or it got the name blockchain. And so, and a lot of people at the time, thought, well, Bitcoin isn't that interesting. Bitcoin is trying to be money. We don't need money. We have money. But this technology, this blockchain technology is interesting. What is it? And in the simplest terms, blockchain is simply a new type of database. It's a new way of storing data. So just like Microsoft SQL or Oracle, like that, it's a database, except it's a really secure database because it can be on thousands of computers simultaneously. It can be a transparent database. You can see what's in there. But because it's so secure, it's also really, really slow and expensive. And it's really simple because you're putting the data on thousands of computers. So you can't store a lot of data. So it makes it really expensive. And it has to compute essentially the stored procedures on all of those servers, which makes it more expensive. So it's this really, really secure, transparent, decentralized database, but it's also really, really expensive and slow. And so that's a really important characteristic of blockchain, the technology. And, if it gets used, people don't know what database, their software uses. They don't know if it uses Oracle or Microsoft SQL or whatever. And long term, they don't really know what blockchain or what type of blockchain there is. It's just a database that you choose for certain situations. But then you get into Bitcoin and crypto, and the simple really difference is Bitcoin, is money. It's trying to be money. And that's the use case. That's the problem it's trying to solve. No other crypto, even though they're called cryptocurrency, its currency is money, they're not trying to be money. Bitcoin is the only one that's trying to be money. If you look at all of the other cryptos, you can look at their use case and take Ethereum, the next biggest one. Its stated goal is to be the world's decentralized compute. It added smart contracts. It's trying to, if you look at its competitors, its competitors are centralized compute, like Amazon Web Services or Microsoft Azure, or Google type of a thing. It's that centralized compute, and it wants to be decentralized compute. But anyway, you can look at all of them and they have a stated goal and it's not money. So that's kind of the big first sort of explanation. Database, Bitcoin is money. All the other cryptos are really a startup. They're a stock. They're trying to solve a certain problem. Does that make sense?
It does. So let's start with the next question. Why is anyone excited about cryptocurrency then?
Well, that's a good question too. Why people are excited about Bitcoin is because our current money is likely broken. And so you'll see this in the form of talking about there's lots of inflation or there's lots of money printing or the money, is controlled by the government. Some people like those things, and I would say a growing number of people don't like those things or they question them. And people need to decide individually what they think about that. But so what's to like about Bitcoin? If you like money that is, I guess it's more like gold. Gold can't be printed. There's only a certain amount of gold that exists, and the supply grows by 2% every year. That's why gold became money. Bitcoin can't be printed. There's only 21 million. It can't be controlled by the government. Censorship resistant. You can't stop transactions. You can send Bitcoin anywhere in the world instantaneously, type of a thing. So that's the attributes that people like. The attributes of other cryptos, again, they're like startups. So if you could go and find a startup that doesn't use blockchain, if you like the problem that it's trying to solve, then you're going to like the crypto. Now, most cryptos, they were very scamish. People were just trying to raise money and then run. Or they were solving silly problems that didn't need to be solved because it was a bunch of hype and people thought they were buying the next Bitcoin or that type of thing. So it's the same reasons that we invest or look at any other type of investment. It's like, well, what problem is it trying to solve? Do you think that problem has legs? Do you think that problem will earn revenue, earn a profit? Well, then you would like it.
Okay. But go back to the differences in cryptos as currency.
Yeah, so there's two reasons that those were called currency, cryptocurrency. One is because they were trying to be like Bitcoin. And so Bitcoin is trying to be money, trying to be currency. And so everything else that used blockchain just sort of grabbed onto that and said, oh yeah, we're money too. And they just kind of got all thrown into this bucket. But the second reason is they, take Ethereum, for example. Ethereum wants to be, a decentralized compute environment, meaning it's added smart contracts to Bitcoin. And so, run all of this code on thousands of computers. Well, to run transactions on Ethereum, you have to pay for the transactions and you have to use the Ethereum token to pay for the transactions. And so in that way, it's like currency. It has an attribute of currency of it's a medium of exchange. It uses the token to pay for transactions. And that's new, that's interesting, that's different. But it's questionable. And so people think that all of these cryptos are going to get higher in value because you have to use them to pay for transactions on their network, sort of one of the attributes of them. And then therefore people will hold them more and buy them more because you have to use them, accumulate them to pay for transactions. The kind of the interesting flip side to that is if that were true, if that's successful, then what we will see is Apple will force you to buy Apple stock to pay for transactions on the Apple network. You'll see that with Twitter or Facebook or places where consumers need to pay for things. Oh, you have to buy the stock, or even businesses, to pay for transactions on this network. Personally, I don't think that's going to happen. And so I think the whole part of using a token to pay for transaction isn't going to happen very often, if at all. The more interesting part about the cryptocurrencies besides Bitcoin is they're a new way for a group of people to raise money for a project. And today, if you want to raise money, there's a lot of regulation. If you want to go public to sell your stock to raise money for a project, there's a lot of regulation. It's very expensive. It doesn't happen until a company is 5 to 10 years old to raise money from the public. And that's what crypto was doing. It was raising money from the public so that they could work on a project without forming a company. It was just a group of people that came together and thought, oh, this project is cool. I want to work on it. Well, let's create some tokens. Let's give some to the founders, and then let's sell some to the public to raise money so that we can work on it. That was it's crowdfunding on steroids. But today, crowdfunding, is limited. The government says, the regulations say you can only raise like $12 million. There's a limit to it. And crypto, it wasn't following any limits. It wasn't really following any regulation. It was just going and raising money. And to their credit, they would go to the SEC and say, tell us what to do. And the SEC wouldn't tell them what to do. But that's actually the most interesting part of crypto, is a new way for a group of people to quickly come together to raise some money and to work on a project, and to be incentivized by a token. And that's why they work on a project, just like a startup. And, just like all startups, most of them are going to fail. So they're risky ventures. But those are some of the other.
But doesn't that also make it easier for criminals to use cryptocurrency to move money around?
Yes and no. Bitcoin's first use case was largely criminal, and which isn't unusual. Criminals usually adopt a new technology first. It's actually also an indication that a technology is useful, is good. What's interesting is criminals thought Bitcoin was anonymous, and it's not. It's completely transparent. It's what's called pseudonymous. And so criminals started getting caught using Bitcoin, because you could track it to some degree if you aren't super, super careful. But then you start getting into, well, criminals don't need permission from government to make transactions. Sort of this know your customer, KYC, or anti-money laundering, these regulations that are supposed to stop criminal activity and transactions. The thing is when you look at those regulations, they don't stop criminal activity. The amount of criminal activity that happens with the dollar keeps growing. It isn't stopped. Criminals just go around those regulations, and they still use the dollar to do criminal activity. And so it's interesting that people will think, or regulators will say, hey, we're doing this to prevent criminal activity. But in reality, it doesn't prevent criminal activity. The criminal activity keeps using the dollar. It will always use the dollar. It will always use whatever money is out there. It's a little bit of a red herring. Does that make sense?
Yeah, because I always hear that, if people get hacked with malware, that the criminals are getting paid the ransom that they're asking for in Bitcoin.
Yeah, that's another actually angle too. That does happen.
It happened to me, as a matter of fact. Personally, I had malware put on my computer, and they took control of my data, and said if I want my data back, pay X number of dollars, but pay it in Bitcoin and by this time frame. I finally said I'm not doing that, obviously, and I threw my computer away and my data, and I had backed it up, thank God. And I ended up being okay. But that's the way they were trying to get me. They were, extorting me to get money or currency for what they were doing, which was holding my data ransom.
Yep. Yeah. So this is a really good example. So here's a question related to that. It's like there's two ways to stop that. One is go after Bitcoin and try to make it so that criminals can't use Bitcoin. The second way is, well, make software more secure so that they can't hack it. Neither one is perfect. We'll never have software that is completely secure, although it's interesting that Bitcoin has never been hacked, but it's really expensive to achieve that. And we'll never have a money that criminals can't use. And in my opinion, what happens is we go to trying to control the money for nefarious reasons, and we never address the root cause of, well, just make this software more secure. That'll actually work better.
Well, that gets us to my next question, because isn't blockchain more secure because of how it's developed?
It is more secure. Well, the Bitcoin network is. The other networks, not so much anymore. This is really interesting. You get into this proof of work versus proof of stake idea. Are those terms familiar? Do you?
Slightly, yes. I'm not a
Uh,
novice at this, so very,
yeah. Proof of work. This is it's related to sort of the energy consumption discussion around Bitcoin, right? That Bitcoin consumes a lot of energy. That's familiar, right? Well, the reason that Bitcoin consumes a lot of energy is that's how you achieve security is with computers. To attack Bitcoin, you have to amass a whole bunch of energy in computers because that's how Bitcoin protects itself by consuming a lot of energy and using a lot of computers. That's how you get security with blockchain. All of the other blockchains, some of them started with that concept of using, well, they all started with that concept of using a lot of energy like Bitcoin, but they dropped it because it was too expensive. It's too slow. And so it's super ironic and it's super interesting that you can start to really question these other blockchains. Do we really need them? Because they no longer use proof of work. They no longer consume energy. So they no longer have the security that blockchain provides. And so it's like, do you need them? What are they good for?
but
But
what's the difference then between those the new blockchain networks versus blockchain that consumes a lot of energy?
so then you get into what they move to is proof of stake. So that means with Bitcoin, the computer that processes, that wins the race to process transactions, to win the reward, to win the transaction fees, and the mining reward, the Bitcoin, they have to use a lot of energy and then solve the math problem, and then they win. And then another block of transactions gets added. The difference with a non-energy consuming blockchain, proof of stake, it's the servers that want to participate, they put up stake. So they they put a deposit of tokens. So the richest, the most wealthy computers are the ones that make the decision about which transactions go into the ledger next. And so in a way, it's very similar to how society works today, is those with the money make the rules. Those with the money decide the transactions. Those in power, those in control decide. And that's the model that the other blockchains have used to. It's like if you stake enough tokens, if you put up enough of a deposit, then you can decide what the transactions are. It no longer uses energy to decide what the transactions are.
All right. I think
And so then you can ask, well, why do we need that?
yeah, exactly.
Why is it different than what we have today? And this is really interesting too. So let's use a use case. And one of the simplest use cases is if you and I enter into a contract. So I'm leasing, let's say I'm leasing a building from you, and we have a contract, and the lease is the contract. And so we each want a copy of the contract, an electronic copy of the contract. So you have your copy and I have mine. And then what we do is we say, well, let's do something called hashing of this contract. So this is a technical term. We can run this contract, the actual text of this contract, through some hashing software. And what that'll do is it'll spit out a 32 character unique fingerprint for that document, right? So if one single character of that document changes, it would spit out a totally different fingerprint. And you could hash, the Library of Congress down to 32 bytes. And if you change one single character in the Library of Congress, it would change that fingerprint. So you and I, we hash this, and it's like, well, where are we going to put this 32 bytes, this hash? We need to store it somewhere. I'm not going to trust you to store it because you might change it, and you're not going to trust me to store it. And so the idea, the concept is, well, let's store it on one of these proof of stake blockchains because then it'll be transparent. We can see it. It'll have a date. It'll be on all of these computers, multiple copies. And then later on, if we want to renegotiate the lease, if you give me the contract, I can check it to make sure that it is the original. I can rehash the one that you give me and make sure it equals that fingerprint that's stored on that blockchain. Does that make sense?
Yes.
Okay. So what we're doing is we don't trust each other. So what we're doing is we're going to trust a third party. And the third party is this blockchain that is run a lot of times these blockchains are run by a group of companies, by a foundation. So we're trusting, a foundation, a group of 30 or 40, large corporations, that type of thing. So instead of trusting a single party, we're trusting multiple parties that have formed some type of organization. And people have a sense that's more trustworthy than trusting, because we could also take that hash and write it to an Amazon server. And then we're trusting Amazon to never change that, to not work with you to put a new one out there, not lose it, or those types of things. Writing it to Amazon will be cheaper and faster. Because if I have to write it, even those proof of stake blockchains, even though they don't use energy, they're still more expensive because I have to write it to thousands of servers. And whereas Amazon, I'm writing it to one server and then they back it up, to various places. And so it's like, okay, do I want to pay more and write it to this proof of stake blockchain where I'm trusting, 10 or 50 parties that came together to govern this blockchain? Or do I want to pay less and write it to Amazon? And yeah, I'll trust Amazon. They're incentivized. They're not going to do anything bad, because if they did, their business would go under. That's the decision that the market is going to have to make. And by the way, Amazon already has something like this that runs. It's called Quantum Ledger Database. It doesn't get very much usage yet because blockchain doesn't get very much usage yet. But that's what the market will have to choose between.
Elaborate on the comment that you've made, I think before or in a previous conversation we've had, which is blockchain is the simplest, slowest, and most expensive database ever created. So then what's it good for?
Yep. So it is it's simplest. If you looked at take a SQL, a relational database, you can define tables and relationships between tables and sort all sorts of complex data, right? With blockchain, you have 1,000 byte of a record, and it's not structured. It's just the best way to think of blockchain is an Excel spreadsheet, and you can't even go and change previous rows. All you can do is add new rows that replace or update previous rows. And it's really simple. All you can type into Excel is kind of text. And you can't even really do formulas in a blockchain. Smart contracts are sort of like stored procedures, but it becomes really expensive. If you run a stored procedure in a relational database, you're essentially running that stored procedure on one computer. In blockchain, you're running that stored procedure on thousands. That's always, always, always going to be more expensive and slower to run a stored procedure on thousands of computers. That's why they're moving the smart contracts off of layer one, off of the blockchain, because they're too expensive. They're too slow. It costs too much. It won't scale. And so you can't put very much data in there. And when you do put data in there, it's really, really expensive because it's on thousands of computers. That's the rub. And so when is that useful? Well, we know it's useful in money, in the Bitcoin use case, because everybody wants to control money. Everybody needs money. Transactions need to be secure. Money needs to be secure. People will pay for, this has been demonstrated already, through Bitcoin's success. Apparently people will pay to use a real expensive blockchain for money. And it's been proven that people won't pay because they got rid of proof of work and moved to proof of stake. People won't pay a lot for decentralized compute, which is what Ethereum is trying to do, or, what the other use cases, decentralized DeFi, decentralized finance, trading, tokens. They won't pay a lot for that. And so, and they need more sophistication than just a simple, 1,000 character field that doesn't do much. And so that's the interesting part about this whole thing of, well, when do you need it? And not very many use cases because people won't pay. And we don't even know the answer to that yet completely because the market, it's still young and the market is still figuring that out. And I I don't even know the answer to it yet. We're going to have to wait and see what it gets used for.
Well, we're running out of time, unfortunately, because I could spend a lot more time with you. Is there a final thought you want to leave the audience with?
Sure. I think another way of thinking about this stuff is the impact, the size from a money or from a dollar, financial perspective. And I think another way of looking at this is, what's the size of money in the world? And that's like 100 to 200 trillion dollar problem. That's the problem that Bitcoin is trying to solve. Then you look at what's the size of crypto, all of these cryptos and the problems they're trying to solve, that's probably Web 5, 5 to 10 trillion dollar problem. And then you look at, well, just blockchain by itself as a database, how big of a problem is that if it's successful? Maybe it's a $500 billion to $2 trillion problem. So looking at it through that lens, I think really helps people understand better, what these three things are. Bitcoin, money, very, very big. Crypto, a bunch of startups. Interesting if any of them work. It's a new way of raising money. Blockchain, just a database. What's the market for a database? And this is a very specialized database.
Okay. Well, I want to thank you for this stimulating discussion and for really explaining. I got a much better understanding of the differences between blockchain, cryptocurrency, and Bitcoin. And for taking the time to be with me today. That really was helpful. How can our listeners contact you if they have any questions?
Yeah, the best way to contact me is on LinkedIn or on Twitter. Twitter handle is ATTNJDW. It's like attention, my initials, or contacting me on LinkedIn. And they can also reach out to me via email. It's john.west at vercey.com, VERCEY.
John, thanks again.
Thank you, Ken.
Don't miss out on the next episode of Technology when we'll discuss how technology is changing the world in a lot of other business sectors. Remember, you can always find Technology Podcast on Apple, YouTube, and Spotify. And if you need help with any size technology challenge, please contact Performance Business Solutions at performixbiz.com. I'm your host, Ken Umansky, and until we meet again on another technology podcast, keep innovating.